All right, let's take a look at your chapter 9 homework. This is problem 1, and we're going to be going to do a confidence interval. And in this problem, it looks like it says they have a sample of 49 observations. It's a normal population, so we've got sigma is equal to 10, x bar, which is our sample mean, is equal to, what's that, 55? And of course, our sample size is 49. So if you recall, remember our formula that we're going to be using for our intervals will be x bar plus or minus z. We're using the z value because this is a sigma known scenario where you know the population standard deviation plus, and then multiply that by your standard error, which is multiplied by sigma over the square root of, and I'll put a parenthesis in there. So that's our formula. We got to get the z value and then calculate the standard error. You multiply those two. That gives you what is called the margin of error. So in this case, we know, again, that to get the z value, we got to know our confidence level. So at 99%, they're basically saying, let me draw the picture here. If x bar is in the middle, at 99%, you want the z value at those two data points. So basically, you have to divide this in two. So you just take 99 and divide that in half. And what happens is when you do that, you have to go into your table. So let me do that. Let me do a different screen share with you. And now I'm on your, this is your normal curve. So if you take the 99 and divide that by 2, you're going to get right at 0.495. So once you get 0.495, let me write this up here. So you've got at 99%, divide that by 2, that's going to be right at 0.495. If you go to your table, you'll notice that it's going to be one of these two numbers right there. And so they're just going to say, go ahead and use 2.58 as your z value. So that's how you look that up. So let me go back and show you the calculation. So again, so what they did was, and the calculation is right here. So the sample mean is 55 plus or minus 2.58 based on 99% interval. That's how they got that. Multiplied by 10, which is sigma, over the square root of 49. And then that's going to give you your margin of error. And so you add and subtract this margin of error from 55. You get about 51.32, and then you get 58.68. That's going to be your interval. All right, so that is my comments for number 1. Let's check out number 2. And some of this is a little bit of review. So they want the standard error of the mean. And notice that's your sigma divided by the square root of n. So they give us sigma, which is 25. And our sample size is 250. So our standard error is 25 divided by the square root of 250. They took this out to 3 decimals. That's fine, 1.581. So we got our standard error. And then on this one, they want 95% confidence. It's the z table again. And I'll just kind of draw you the picture here, what you're trying to look up. So essentially, let me move this, my mouse. I'm moving my mouse. That's why you don't see it right now. But essentially, what this is the interval. Let me clear that. Sorry about that. All right. So what happens is your interval is in between. So again, let me get to my curve. There we go. So they want us to get the 95% that's in the middle. So your z value is it's going to be the same z value. So what you essentially do is you cut this in half based on our table. So it means zeros in the middle. So essentially you got 0.475 and 0.475. So you go to your z table, you look up this area, and that's going to correspond to a z value that's equal to right at 1.96. And so in your calculation, it's simply going to be, remember, it's x bar plus or minus your z value multiplied by sigma over the square root of n. So since we know that the sample mean is 20, so you'll take 20 plus or minus 1.96 multiplied by 25 over the square root of 250. and then that's going to be your answer to how do you get these two numbers. So the 1.96 multiplied by your standard error, that's going to give you times 1.96, that'll give you what they call your margin of error, and that you should be able to add, subtract that from 20, and they take these out 3 decimals, so you get 16.901 all the way up to 23.099. All right, so that is problem 2, and of course down below you can also see their calculations for both A and C. All righty, let's check out number 3. And on number 3, it's just a question to see if you know how to look up the z-value. So they're saying, suppose you want 85% confidence using z, what would be your z-value approximate? And again, what you'd simply have to do, just to kind of map this out, is you would just draw on your curve, and that they're just basically saying 85% is the middle, and you want to cut that in half. So you take your 85, and you divide that by 2, and then that'll be the area that you want to look up in your table. So if you take 85 divided by 2, that's right at 0.425. So what you do is you go to your table and you try to find an area that's equal to 0.425 in your table, and you'll find out that it's going to be right around 1.44. And so let me just show you, I'll just, in case you're wondering, let me show you that in your table. My annotation, here's my table, there we go. There you can see it's right there. Notice you got 0.4251, that's close enough. So use 1.44 as your approximate. And that's how you do it. All right, let me go ahead and erase annotations. It's gone. All right, cool. All righty, so that is number 3. And now let's check out number 4. So on this one, whenever they say point estimate, that just means that's going to be your sample average. So in this case, your sample mean was 20. That's going to be your approximation of the population. So you just plug in 20. That's going to be your X bar, or again, they call it your point estimate. And then again, at 95% confident, we know that our z-value is going to be 1.96. So again, we're going to plug that in. You would have 20 plus or minus 1.96 multiplied by sigma, which is 5, all over the square root of 49, because that's your sample size. All right. So once you do that, you can plug that in there, and that's how you should be able to get your confidence interval. And then let me show you, I'll just show you since I got it up here, you can see the calculation right down below. 20 plus or minus 1.96 times 5 over the square root of 49. That's going to give you these two numbers. So they take this one out to 2 decimals, it looks like. All right, so at that point, on the next problem, they're going to get into the t-distribution table. So I'm going to save this, and I'm going to show this on a different video because I got to change tables. So I'm going to call this your chapter 9 homework part 1, and in part 2, we're going to get into the scenario of the sigma unknown.